Right, welcome to this video. We're going to be talking today about multiplying and dividing algebraic fractions. We just finished talking about adding and subtracting them, and now we're moving on to multiplication and division. Hopefully you will remember that similarly with multiplying regular fractions and dividing them, it's much easier with algebraic fractions than adding and subtracting. Okay, there's some reasons for that, but essentially it's way easier, and this is the sort of stuff that you should just sort of fly through. Again, similar to the last video, I'm just going to cover a couple little things and then go through some worked examples to show you what it looks like. Okay, so a couple of things to know that when you are multiplying algebraic fractions, simply multiply the numerators together and then you multiply the denominators. So maybe a quick little reminder for you. If you just drag up here for a sec, 3 over 2 times 7 over 8. 3 times will be 3 times 7 over 2 times 8, which is 21 over 16. Okay, and you're done. Leave it like that. Now remember, you guys have got calculators now, so you can just type that in your calculator and it'll do it for you. So please don't hesitate to use that if you need to. Now, when dividing algebraic fractions, remember you flip the second fraction and then multiply. So a quick little example. If we had a half divided by 9 over 7, we would rewrite that as a half times, and we flip this thing over to make it what's called the reciprocal, the sort of the opposite. It's kind of what you want to think about it as, and that becomes 7 over 9. And then now this is an easy one to do. 1 times 7 is 7, 2 times 9 is 18, and we're done. Okay? Right. A couple of worked examples with algebra ones now. Okay, so I'm just going to quickly go through these because it's quite easy. So we have 9y over 5 times 2x over 3, and we simply multiply our numerators. So 9y times 2x over 5 times 3. So denominator is easy to work out here, it's 15. But remember from a couple of videos ago when we were talking about multiplying algebraic expressions. So we have a 9y times a 2x, remembering that we multiply our coefficients together. So these two, 9 times 2 is going to become 18. So we have 18, and we multiply our letters, y times x. You could just do yx, but remember we try and write in alphabetical order, so we'll have 18xy. Now, these ones here, 18 over 15, like you should always check these fractions to make sure that you can't simplify them. In this instance, 18 and 15 have a common factor of 3, being its highest common factor, so you could have, you'll end up having 18 divided by 3 is 6xy over 15 divided by 3 is 5, and you're done. Okay, so as you can see, that's much easier than the addition and subtraction of fractions. Just the whole process just happens a lot quicker. Right, so another one here, 10x squared over 7 times 3y over 5x. So I'll just rewrite that here for myself, 10x squared over 7 times 3y over 5x. Okay, so what's our new numerator going to be? Well, it will be 10x squared times 3y. Our new denominator will be 7 times 5x. Okay, now let's have a look at the denominator first. It's probably the easiest one to sort out. 7 times 5, we multiply our numbers together. 7 5s are 35, and we only have one letter there, so it's just 35x. On the top, 10 times 3 are our numbers, so that's 30. And x squared times y is x squared y. 30x squared y over 35x. So a couple of things that can be done here. We now need to investigate our fraction and say, can we simplify this? Okay, so let's have a look at the numbers first. So essentially we're grabbing the numbers here. Can we do anything with these ones? Well, they're both divisible by 5, so this can change to 6 over 7. Okay, right, what about our letters? Well, we can rewrite this part here as, if you think about it, that it's sort of x squared is the same as x times y, so that's x squared y over x. Remember, they're cancelling across the fraction line, the vinculum, that if it's the same letter or with multiplication and stuff, you can cancel them across the fraction line. Okay, so we'd be left here with a new fraction being 6xy over 7. Okay, so a lot of things happen there. Please remember that in these videos you can rewind and sort of watch me go through it again a couple of times to make sure that you understand everything that I'm doing as I progress through the problem. Okay, right, an example using division this time. So I might just use this fraction, save me rewriting it. Now remember, with division, the first thing you do, write down the first fraction unchanged, 3y over 4. The division changes to a multiply, and then you flip this one over to create the reciprocal. So it becomes 3y over 4 times 2y squared over 3. Now we just go on as usual. So our new denominator will be 4 times 3. Our new numerator is 3y times 2y squared. And 4 times 3 is 12. 3 times 2 is 6. And we have y times y squared. Well, what can we do with that? You may be able to remember that, for instance, if we had 9 times, she might not make it 9, might make it 3 times 3 squared. You could rewrite that as 3 to the power of 3, because it's 3 times 3 times 3. So in the same way, you can rewrite this as y times y squared is the same thing as y to the power of 3. Okay, so that's how we simplify that little thing going on here. We can simplify our 6 over 12 by dividing both by 6. 6 divided by 6 is 1, which we don't write. So our numerator is just y cubed. 12 divided by 6 is 2. Y cubed over 2. There we go. Again, a lot of things happening there, so please rewind that part of the video then to just have another watch through it if you sort of were a little bit confused as to what might have happened at different steps. Okay, this last one. 6j divided by 2k over j cubed. Now, remember, this is an issue with our previous exam. We're talking about fractions, that people didn't deal with our fractions with no denominator written very well when they were multiplying and dividing them. So remember that 6j is the same thing as 6j over 1. We change our division to a multiplication, and then we do the reciprocal of this one here. We flip it over. So we'll have, instead of 2k over j cubed, we have j cubed over 2k. And now we just carry out a multiplication. So our new numerator is going to be 6j times j cubed over 1 times 2k. Well, 1 times 2k is quite simply 2k. 6 doesn't change, j times j cubed. Remember, j times j is j cubed. Okay, so that is j to y. J times j, that's y cubed. If we add another one in there, that's why we get our j to the power of 4. So that would be j to the power of 4. And we can simplify this 6 over 2 here by dividing both of them by 2, divide by 2, divide by 2, and we'll get 3j to the power of 4 over k. Now, stuff like this might look totally gross to you, right? Right? But it's not. Like, those letters just mean numbers. We could change that into just some number, and it doesn't matter. No one cares what they are. At the moment, remember, algebra at this stage is just talking about tools that you can use to solve a problem. Okay? So we're going through the way of how to use this particular tool set to multiply algebraic fractions together. Okay, please don't be scared of the fact that that has just letters everywhere. J to the power of 4. I mean, what's the number going to be? It doesn't matter. You can just use your calculator to come up with some number later on, and don't worry yourself about it. Okay, Just because the letter's in there doesn't make it any worse. We've just got everything super abstract at the moment, and you're maybe not seeing how we're going to end up using it, but once we get in that process, you'll really start to see the power of what algebra is capable of doing for your mathematics. Okay, thanks for watching. Maybe try some of the problems. Otherwise, bring some questions and concerns to class, and I'll see you then.